It's always so lovely to host you every Wednesday of the month. Greetings, fellow readers from the African continent and across the world. It's lovely to have you with us for today's live session. I'm so excited to be here with you today and to be your host for today. Equally excited about today's topic. Before I introduce our presenter, in today's presentation, we will be exploring how to define an area of interest using either a point and buffer or a shapefile or GeoJSON file, and how to use this defined area to clip data sets in order to ensure that the data being used is relevant to the specific study area of interest. Lastly, we will also look at some real-life examples to see how these tools can be used in practice. Sounds like a long thing, but don't worry, it's going to be certainly unpacked today. I'm very excited to introduce to you today's presenter. She's no stranger here at Digital Earth Africa. In fact, she was part of the lineup in our International Women's Day that we hosted in March. She is a colleague, an Earth observation data scientist right here at Digital Earth Africa, to speak to us more about the vector file package for notebooks condition. Please join me in welcoming onto the virtual stage, Mpho Sadiki. Mpho, when you're ready, you can turn on your camera and the virtual stage is yours. Over to you.
Hi, Maud. Thank you very much for having me. I'm very excited to be here because I'm here to present a capability that a lot of our users have been asking for. So I'm sure most of you will be excited to see what we were able to bring into the platform in terms of adding a vector polygon to define your study area. So this is not going to be too long because I won't actually be going through a notebook, but rather just showing you the function that we've created and how you can actually use that function in the notebooks. Just share my screen and then I'll begin with the presentation. So just, oh, sorry about that. So this week's presentation, I've titled it Adding Vector File Support to Notebooks, and this one will be in English, and obviously next week's one will be presented in French by our colleague Joseph. So in this presentation, I will be delving into the topic of defining the area of interest within the sandbox. We will explore two primary ways of doing it: the original way, where you can just define your point and a buffer around it, and then obviously the new way, which includes adding a shapefile or a GeoJSON file to define your area of study. And then we'll just look at two examples with two notebooks where these were actually applied and how that works. So just to remind everyone that the Digital Earth Africa Sandbox is a cloud-based computational platform that operates through the Jupyter Lab environment and provides you with limited but free compute resource for technical users and data scientists to explore all the data and products that we have as Digital Earth Africa. And most of the examples that we have can be found within the real world examples notebook folder, where you can interact with different types of problems that you could encounter in the real world. So why are we adding this vector file support to notebooks? It's because the old way, as you can see in the image attached, defined an area according to a point, which is a latitude and a longitude, and creating a buffer around it. However, users did request flexibility in terms of defining the area of interest, because if you use a point and a buffer around it, it's sort of restricted to a square or a rectangle as your study area. But what if you have a more defined area that you want to work with? So we added the capability to add a shapefile or a GeoJSON, which can allow you to define the boundary using that custom vector file. And this capability then offers you freedom in defining the study area in your notebooks. So with the vector file support, we created a new function, which this function is in the Africa tools folder in the sandbox. So it's called area of interest, and it contains a function that we call the define area, which we use to define an area of interest for the analysis in the sandbox. So the function takes either a point or a buffer to create the study area, or a shapefile or a GeoJSON. And as you can tell, I'm repeating this for the 100th time already, but that is the focus of this entire presentation. So if you have a point and a buffer, you create a bounding box around that point. And if you have a shapefile, it creates a bounding box around the overall extent of that shapefile or GeoJSON. So this is just the code in the function. As you can see that the function defines an area of interest, and you can either define the latitude and longitude in the buffer, or you can give a vector path to a vector file, which is either a shapefile or a GeoJSON, and that will be converted to a geopolygon that you can then use to load your data and then subsequently continue with the rest of the analysis. So if you are to use this function, and as I said, we included it in the DE Africa tools folder. So to use it, you need to import it into your notebook using this code. So from DE Africa tools dot area of interest. So that is the name of the file. Import the function define area. So that's how you bring it into your notebook. And when you get into the notebook, you will see this code, which you can then use to define your study area. So the code has method 1, where you specify the latitude, longitude, and buffer. So this is the default method that is being used at the moment. But it also has method 2 that you can see here is commented out. So that is the option that you would use if you were to use a shapefile or a GeoJSON file. And once you've selected either method 1 or 2, it creates a geopolygon, and then you can obviously display it on a leaflet map, overlaying a leaflet map as well. So to use the point, it's pretty straightforward. You do it the same way you did it before. You just add the latitude value, the longitude value, and the buffer, and then the function does the rest for you. So if you want to use a GeoJSON file, that's there's a few extra steps that you need to take. So the first thing is you'd obviously need to have your GeoJSON or shapefile ready, and you'd need to add it into the folder that you're working within as well. So to do that, you would have to use the upload files button or icon to bring in those files into the sandbox. So if it's a GeoJSON file, you can just upload the .json file. That's the .geojson file, that's fine. But if it's an Esri shapefile, you need to include all the accompanying related files. So the .cpg, the dbf, the shp, and the shx. And they don't need to be in a zip folder, so you can just bring them in as they are. So it's the .shp, shx, dbf, and cpg in order to use a shapefile. But a GeoJSON is just the GeoJSON file, that's okay. So once you've brought them into the sandbox, and it needs to be into the specific folder that you're using or you're working from, you can then comment out the line for method 1 that uses the latitude, longitude, and buffer, and then uncomment the line that uses the shapefile path to add your area of interest. What you need to change then is the name of the path or the name of the file. Here, I'm just saying it's an example. So that means the name of my GeoJSON or my shapefile is example. So I just call the example file that I added into the sandbox, and that will be what is used to create my study area. But as you can see, it creates a bounding box around the full extent of the shape, not necessarily the shape of the polygon that you've added. But that is not a problem, because later on you are given the opportunity to actually clip to that study area that you want. So just to show how it works, I'll go through two examples. The first one is the burnt area mapping, which is a notebook that calculates the changes in the normalized burn ratio between a baseline composite and of the pre-fire condition of a selected area and a post-fire event image. So as you can see, I've highlighted two steps in the steps that were taken because those are the ones that I'm interested in. I'm not going to go through the entire notebook to show you how that notebook works, but rather just to show you how this particular capability can be applied to the notebook. So it's all about selecting the area of interest, and this directly influences the loading of the baseline data, which in this case is the Sentinel-2 data. So when you open your notebook, you will see under analysis parameters, before you would just see this top part where it says lat, long, buffer, fire date, baseline length, and this would be repeated for the other notebooks as well, obviously without the fire date and the baseline length, because that is specific to the burn area mapping, but rather the latitude, the longitude, and the buffer definitions, these you would see in other notebooks as well. But now we've added an extra description which provides you with more information of how to select an area. So you can either use that first method that you used to, which is the latitude, longitude, and the buffer, or you can go for the uploading of a GeoJSON file or an Esri shapefile to define your area of interest. So I will show how these work, just a repetition of what I said before. So with method one, you just give the lat, the long, and the buffer, and the function does the rest for you. And you can see that's the area that we've selected. So for method two, where you add a vector file, this is the vector file that I created as a test. So this is example.shp. And remember, when you add it, you need to add all the accompanying files of a shapefile as well. But if it's GeoJSON, the GeoJSON file is by itself is fine. So you need to comment out the first line that defines the area using the latitude and the longitude, and then uncomment out the one that uses the shapefile or the GeoJSON, and then just change the name to the one that is correct to your particular instance. And that will just show you where that is drawing. So as you can see, it's not the exact shape of the shapefile that I added, but it does take the overall extent of the area. So what this does, it affects when you load your data from the data cube. So in order to load the data, you can obviously use the tried and tested method of using the X and the Y, which is the longitude range and the latitude range, or you can just call the geopolygon, which is essentially the same thing. So it's either you can use the geopolygon or the latitude and the longitude range. So it's the same thing. It will just give you the data for the bounding box that you have defined. So with the burnt area mapping example, you can see that with the so what I said was it takes the extent and not the shape. And this is where we created or added the capability of clipping the data set to the shape of the area of interest. Obviously, if you're using a point and buffer, clipping really does nothing to your data set. So it still comes out as it is. But if you are using a shapefile or a GeoJSON file, you can see that you can clip it and it will take all the vertices of the study area that you want. So the reason that this may be important to you is because maybe you're looking to focus on a specific study area without interference from areas outside. So because if you take just use the extent, you might be including areas that you do not want to include in your analysis, and that could tamper with your outputs. But if you don't want that and you want to restrict your study area to the exact shape of your vector file, then you would have to run this a cell as well. So the cell takes the geopolygon, which you created here from either the burnt, from either the point and buffer or the area that you loaded as a vector file. and it rasterizes that so that you can use it to mask the data that you load, your raster data that you load to the exact shape of your study area. So this is not mandatory, but it's if you'd like to do it, it is a capability that exists that you can then use. So another example is the Chlorophyll monitoring notebook. So it's the same thing. It can either load your latitude, longitude, and buffer, or you can do your shapefile or GeoJSON, and you can clip it if that is something that you would like to do as well. So this is really all I have in terms of the capability that we've added with the vector, adding a vector data set to restrict your study area. So if you have any questions, please put them in the chat and let us know if you have suggestions, if you have anything you'd want me to clarify in how to use this notebook. At the moment, this capability is added to almost all the real-world examples notebooks that allow for the capability, but you can use it in any notebook that you want, because obviously you've created the function that you can just then call and then implement in whatever notebook that you'd like. Okay, so that is all for me in terms of that capability, but I'd just like to remind everyone that you can interact with our training courses. You can sign up, you can see the details below, you can enroll into the Sandbox introductory course and masterclass, where you can also have access to self-paced, freely available, fully online videos, tutorials, manuals, and hands-on exercises in both English and French. And you can get a certificate of completion once you've completed your exercises. So please do interact with those training courses and get familiar with the Digital Earth Africa platform. And if you want to learn more, you can go to our website, which is www.digitalearthafrica.org. And you can also subscribe to the community to receive quarterly newsletters and invitation to attend events. And you can do that through the help desk. You can sign up for these weekly live sessions, and you can connect with us, and you can also email us to ask any questions or any information that you'd require. So that is all for me. Thank you very much. So if you have any questions, please let us know or let me know so I can clarify anything. And if you have any suggestions, please do let me know and we can work further to improve the Sandbox so you can use it better. Thank you.
Thank you to you, Mpho, for that presentation. It was very clear. I'm not in science, and I think I've said this before, but what I love about these live sessions is that even for someone like me who's in a different field, I get to learn. And today I learned about shapefiles, vector files, buffers, GeoJSON, and I feel like I've learned something. So if you have any questions or comments on the specific topic, please do drop them into the chat box so that Mpho can answer them for you live right here on our session. And so much to you, Joseph. We enjoy having these sessions because it gives us an opportunity to interact with our community of users. And so we have these sessions in English and French. If you prefer French, don't worry, we have you covered. We will have that definitely the same topic next week, and my colleague Joseph is going to be the one presenting. As always, leaders, we love connecting with our audience. You know that, and every single event, I always want to extend an invitation to you to connect with us. So on the screen now, you're going to see all the ways that you can do so. Besides the ones that Mpho mentioned in her presentation, you can log on to our website, which is www.digitalearthafrica.org. We're also on email, info@digitalearthafrica.org. And then social media, we're very active in that space. So please do connect with us there, Twitter, LinkedIn, as well as YouTube by the same name, Digital Earth Africa. It's been an absolute honor hosting today's live session. Thank you so much for your time. Thank you so much for your ear. I hope you found it useful. Remember that if you have any questions or comments at any time, you're more than welcome to reach out to us on any of the connection platforms that I just mentioned, and we will definitely answer your question. The same topic, we're going to host it again next week. So don't worry, if you speak French or if you prefer a live session in French, next week, we're going to have you covered. We host these sessions every single Wednesday at 11 a.m. GMT. So you don't want to miss out. So please do connect with us on our platforms, WhatsApp groups, and we'll definitely be able to share that. We're about to take